So it's 14:40. Shall we start? Right, excellent. Thanks for joining this talk, the big cloud-native FaaS Lebowski. So let's talk about function as a service mainly. Let's talk about serverless. And let's talk about why I think this is the next logical evolution in cloud-native application development. So just briefly about me, my name is Leander. I'm a principal software architect. I work in the beautiful town of Munich, so I'm German. I'm a total cloud-native nerd. So what does that mean? I'm researching, cloud-native application development, researching distributed systems. I'm a part-time lecturer in cloud computing at a Polytechnic, the Polytechnic where I study computer science in my hometown Rosenheim. I work for a company called Hardware. We're a small software project house. I have about 100 colleagues working in Munich mainly. And we do software development for German Telecom. I work for BMW mostly, for Allianz Insurance, so for large German enterprises. All code I show you today is on my GitHub repo. I'm sure the slides will be shared afterwards, and you find the slides on SpeakerDeck as well. Now, today is not my first appearance here at Devoxx in Poland. So why is that not working anymore? Oh, let's do that. So 2017 was my first appearance, and I'm totally glad to be here 2 years later. And 2017, my talk was a hitchhiker's guide to the cloud-native stack. And this is where this whole Kubernetes thing, Spring Boot, Spring Cloud thing totally exploded, right? And what I talked about in this talk is that it's been an evolution until 2017 already, right? We had infrastructure as a service, virtual machines. We started with containerization. Then we realized we need some cluster schedulers. We need cluster orchestrators like Docker Swarm, Mesosphere, DCOS, Kubernetes to handle all this workload, right? So it became pretty apparent back then already that there is certainly a huge explosion in complexity and technology stack. And this is where we're today, right? So I would say cloud-native software development is complicated, right? Who would agree with that? It's not so simple, right? Thank you, at least a few hands, right? It's not only microservices. Yeah, I've built this Hello World microservice. But to be honest, in normal enterprises, and I'm sure it's in your company the same, there is no Hello World microservice. There is no A+B microservice, right? We need to develop proper enterprise-grade applications, right? We have to deal with persistence. We have to deal with diagnosability. State management. Sometimes you always say, microservices should be stateless, but at some point you might have some state, some session state. Maybe you have some single-page web application on top, and now you have to stick all of this into Docker. You know how to write a Docker file properly. If you want to stick a JVM into a container, that's not so easy either, right? You have to know about memory management and all those sorts of things. You have the dreaded YAML. You have YAML everywhere. You have YAML in Kubernetes. You have YAML in Docker Compose. YAML is everywhere. Getting your microservices right, getting this right tight slicing of a microservices right is not so easy either. You have to, think about things like domain-driven design maybe. This whole Kubernetes thing is not so easy, right? You have to know about pods. You have to know about services. You have to know about deployments. Maybe you have to know about stateful sets. If you go in the OpenShift route, even more complexity. So I think it's rather complicated. And you have two options to deal with this complicated stuff. Option one is, obvious, make it more simple, right? Simplify your development. And this is one approach. It's probably a totally different talk, but I think it's worth mentioning that to handle all this complexity in this technology stack, one thing is make your development workflow more simpler, right? I heard a talk this morning from Atomist. This is kind of the direction it goes. There's a tool called Telepresence, for example, from Google. You have Scaffold that kind of abstracts all this complexity and all these technology stacks and makes our lives easier as a developer. Now, this is option one. And option two, I think, and this is the next logical evolution that's currently going on in cloud-native software development, is this term serverless, okay? And I think serverless is, in my opinion, the next logical evolution in cloud-native software development. So we came from infrastructure as a service. went the containerization route. We talked a lot about orchestration and, you know, more and more complexity on top, on top, on top. And serverless now is the approach that tries to simplify things a different way. Now here's a rather lengthy definition of what serverless is. I took this definition from the serverless landscape from the Cloud Native Computing Foundation. And they say serverless computing refers to a new model of cloud native computing, enabled by architectures that do not require server management, okay? So what serverless actually tries to do is kind of abstract away all this, I need a cluster, and this cluster is running Kubernetes. On this Kubernetes, I need to run containers, and I need to maybe spin up deployments and you know, 5 replicas of those deployments. So it tries to hide all of this, okay? So that we as a developer, we just say to a serverless platform, hey, serverless platform, give me a piece of code, please execute it. Execute it resiliently, okay? Make sure that every time a request comes in, fire up whatever you feel free to fire up and just make this code execute, right? So ideally I have some form of zip file, and in a zip file I have my business code, my business logic, the stuff I actually want to concentrate on as a developer, and I leave all the rest to the platform to execute. Sounds a bit like magic. What serverless also does is it leverages a finer-grained deployment models, okay, where applications are bundled as one or more functions, okay? This is where the function as a service bit comes into serverless, okay? So serverless is like the big thing, like, you know, you don't have to care about the database management anymore, you don't have to care about servers, so that's kind of the abstraction there, plus this added function as a service deployment model and development model. Okay, so you have your function, you upload those functions to the platform, and the platform takes care of executing your stuff. It scales your function appropriately if you have more load. You build in response, okay, so this is kind of important in a function as a service model. You have this so-called scale to zero thing, right? If no one calls your function, you don't pay anything. You might have heard of AWS and Lambda, for example. This is exactly what we're talking about, right? So you have your function. If your function is called, you build. If it's not called, you don't pay any money. Compare this to, you know, orchestrated containers in Kubernetes. They run all the time, you know, wasting your quota even if they're not called. So in response to the exact demand needed at the moment. So this is like this rather lengthy definition of serverless by the Cloud Native Computing Foundation, but I think it has all the important bits in it. Now let's talk about functions, okay? Functions as the preferred serverless application programming model, okay? Why functions, right? If you may think back to your computer science studies, you know, there are some of those eternal truths, right? And the function is one of those eternal truth primitives. Input, processing, output, okay? This is like the perfect function. A function does not have state, right? Not having state is super fine for cloud native application development, because if you don't have state, you're infinitely scalable, right? So this is why the function itself is a really smart thing to have, right? You have some defined input, you have the function that alters, well, it does not alter the input, it produces new output. So the input comes in, you do some processing, and you produce new output. And this new output maybe then can be the input of the next function, right? So you can have function chaining. Now, of course, this function thing is what you see here is like the next evolution, maybe, right? If you come from the monolithic system, like you have like your development components and you have your ops components. And what we did so far is we kind of subdivided our system into individual components, and we stuck those individual components into microservices. And now we push this lever down even further, and we go on a function or on a service level, right? And let's call those function services. Why do you do that? Well, flexibility and scaling. You want that one. You want a higher runtime isolation, right? This is important in resilient systems. You have a couple of functions. If this one function doesn't run, well, all the rest of the system still runs, okay? And you are still able to serve user requests, maybe. You can have independent releases, independent deployments, independent teams, okay? So you have like small feature teams, maybe 1, 2, 3 people that take care of this function or of this deployment unit and of this function service. And you can have a higher resource utilization. So the infrastructure you have and the infrastructure you pay for is you can utilize this infrastructure a lot better. Of course, you have a few decomposition trade-offs, I call this, okay? And you have a lot of them if you go down the microservice architecture route, right? If you have a lot of microservices that are, well, kind of coupled together, maybe using asynchronous REST API, then you definitely have distribution depth. Sometimes, suddenly latency plays a role, right? Consistency is a thing. You have this increased infrastructure complexity, increased troubleshooting complexity, and increased integration complexity. And this is where serverless really tries to make things simpler, right? So we don't want to care about the infrastructure complexity anymore. It's serverless. The serverless platform takes care of exactly this. Troubleshooting complexity, well, I guess a proper serverless platform should provide some form of diagnosability features to diagnose my functional system or my function-based system. And integration complexity, again, here, I think the serverless approach tries to make things simpler. And this is what we have a look today. How well do the different function as a service platforms kind of address all these issues? The other thing functions really cater for is a thing called event-driven architecture. Anyone knows the term? Does everyone knows the term? Yeah, a few people, okay. Now, we always say that microservices should be loosely coupled. But in reality, the systems we build using microservice architectures, they're not loosely coupled, right? We stick a synchronous REST API between them and let them talk synchronously. And we think that, you know, having a circuit breaker between them makes things, you know, better. But it doesn't, okay? It's a remedy, but it's not the solution. And the solution would be really to go towards event-driven architecture. And you can definitely build event-driven architectures using microservices, okay? But with a function-as-a-service approach, you know, you have asynchronous functions that react to events, okay? They really enable loosely coupled reactive software components and services. So really, if you go down this function-as-a-service route, but also if you're into, you know, microservice architectures or building microservices, make sure you have a look at least at event-driven architecture, because I think this is, again, the next logical evolution in trying to build resilient, loosely coupled systems. One thing you can have a look at is the so-called cloud events standard. What they're currently trying to do in the Cloud Native Computing Foundation is to kind of standardize how those messages, how those events that are exchanged in a system, how, you know, what the exact format should be. They try to standardize how events are then, you know, serialized over HTTP or serialized over Kafka or serialized over any other message bus. They try to standardize the headers of a message and not so much on the, you know, on the actual content. So make sure, have a look at the cloud events stuff that's going on in the Cloud Native Computing Foundation. Now, the Cloud Native Computing Foundation realized that the serverless thing is huge, huge already, okay? So what they did is they have now a separate cloud native landscape. You may know the big cloud native landscape with everything, and this is like the specific serverless landscape. Now you see you have a lot of tools, security, you have a few frameworks, and then you have this huge long bar with platforms. And now we have 45 minutes left to have a look at all those platforms. And of course, that's obviously not possible. So let's try to slim down things. And one thing I really want to make clear, if you go on this route, I really recommend you kind of do the same thing I tell you now within the next 45 minutes and do the next thing for your use cases. Because kind of the evaluation and the comparison I do now is highly bound to the exact use cases I had, you know, in my project or in my, you know, personal interest. Use case number one, hybrid architectures. Now, I talk a lot to colleagues and they say like, yeah, microservices, they're so bad. You should be building every system from now on using function as a service. And I'm kind of old, I'm 42 now, and I say, don't you think that's a little too early to go down this function as a service route? You know, my customers I work for, they just started to comprehend this whole microservice thing. If I could go to them the next morning and tell them, well, microservices, yeah, we went totally the wrong path. Let's build everything from scratch using functions. I guess you know the answer I get. So what I think is a more sensible approach is, hey, why not combine microservice architectures with event-driven architectures? We've been building our microservice-based system for the last 2 years. They're hopefully not all that bad, right? They work and they're running. Yes, they have their weaknesses. But how about a slow migration? How about getting this first impression on how does this event-driven architecture thing feel like? How does this function as a service development model, what does that feel like? Can we kind of leverage the strengths of both, right? If I have an event-driven use case, you know, sensory data coming into a Kafka topic or something, hey, that would be a perfect use case to maybe apply a function instead of building the next microservice. Also, I'm interested in, you know, can I maybe reduce the resource consumption and the costs, you know, when you're on a shared enterprise platform like OpenShift, for example. And one thing really important for my use case, for this use case, is how well does this function as a service platform integrate into an enterprise PaaS like OpenShift or Kubernetes? Because all enterprise customers I know, they've been investing massively in, you know, cloud-native architecture. They're building their Kubernetes clusters and OpenShift clusters. If I tell them, well, I don't want to use those anymore, here is a new platform, I know what the ops team says, right? So this was a very important piece for me as well, okay? So how can I integrate microservices with my function services? Both ways. Can function services call microservices? Call microservices? How can microservices maybe invoke function services, you know, via messaging? How well does the platform integrate? Does the FaaS platform integrate nice with my logging, monitoring, and tracing infrastructure I maybe have, right? My Elk stack, my Elastic stack, my, I don't know, my Dynatrace APM, whatever I have in an enterprise environment already. How well does the FaaS platform integrate here? So this is kind of the enterprise use case I'm after. The second use case is edge and fog computing. I don't know if the term is familiar yet. Edge and fog computing is basically how can you use cloud-native technology on low-power devices, maybe in an IoT use case, right? So this is like pushing the compute again further to the devices. So you have some temperature reading, or you have some really mechanical stuff, and you have low-power devices like this here, my little toy box, right? To have like a bit of pre-processing of event data close to the source of the events, right, in an IoT use case, and then send the data maybe off to the cloud somewhere. So what this here is it costs €100, I think. Okay, so this is a Raspberry Pi 3 at the bottom, and it has 4 Raspberry Pis 0 on top. Raspberry Pi 0, €7. The Raspberry Pi 3, I think 35 or something, plus the box, plus a bit of cables, 110 or something, I think it was. And it runs Docker Swarm, okay? Kubernetes would be a bit too much for this one, but it does run Docker Swarm. And I was really interested in, hey, how can I leverage like this function as a service thing to run like small, probably Go or definitely compiled languages, especially on those Raspberry Pi Zeros, because they're not fast, right? They don't have much memory, right? They have like half a gig of RAM, okay? So putting 1 JVM on this one so I can run one function. So I was really more into compiled languages like Go. So those were my 2 use cases, okay? So this is my private interest toy project plus my enterprise project use case. So let's see. Let's define a few criteria. Well, I like open source, and if you start things, I think it's important to have no initial costs. And no vendor lock-in, please, right? This is important in this toy project, of course, but also in an enterprise level, right? My customers have invested serious money into, you know, building up their cloud-native platforms in-house, and it's always better to sell a new technology if you say it's for free. It doesn't cost anything. Maturity, of course, especially in an enterprise level, this is important. How mature is the platform? You know, if I make a strong recommendation towards my customers, I want to make sure that it's not dead in the next half year. So how good is the community? How active is the community? You can have a look at GitHub issues, for example. I mean, are there many bugs or no bugs? How fast are they fixed if there are bugs? How many committers are there? You know, is it a one-man project, or is it like, you know, active, vibrant community of 100 committers? Are there frequent releases, or was the last release maybe 1 year ago? Yeah, and now dead. So maturity, we will have a look at. Of course, the use cases are kind of important. There are platforms that, for example, position themselves really in a big data environment or in the AI environment, or maybe edge computing. So again here, quick look at the use cases. I think it's always nice how approachable is this whole thing, right? Do I need to spend, you know, 5 days to get this stuff running, or do I manage to get like the bare minimum Hello World example running in 15 minutes, right? And I would trust this 50 minutes thing a lot more than, you know, investing 5 days and to get things run. So is there a quick start? Is there sufficient documentation? Do I feel confident as a developer with this? How many language runtimes are they supported, right? And the most function as a service things you see, there's always JavaScript. Yeah, maybe TypeScript. Yeah? And I'm definitely not a JavaScript guy. So are there proper languages? Like, you know, are there Java? Is there Go? You know, how many languages does it support? Because every language has its strengths in certain parts, right? I mean, Java is super fine in an enterprise level. Java is probably not the right language in an IoT device level, right? Too bloaty. This is where I would rather use the Go version, or maybe, yeah, even the JavaScript version is in an IoT environment a pretty good choice. So how many language runtimes are there? Developer friendliness, right? It should make things simpler. So tools and frameworks, how about there? Is there a local runtime? Can I develop my stuff locally on my laptop, or do I always need to go to the cloud? How about testing? How about IDE support? Is there maybe a nice fancy IntelliJ plugin for it to make things even more easier? Operability, right? If I want to recommend this platform later to my ops team or to my site reliability engineering team, it's kind of important that the setup is easy, that there are a lot of supported platform, and the technology footprint is not super heavy, right? Especially on a shared cluster. If I tell them, well, this platform needs a Kubernetes cluster, a 7-node Kubernetes cluster with 250 gig of RAM, and then they say, okay, that's not so lightweight. You know, I want to have a slow approach. Integration. How many supported triggers are there? Is it only HTTP? How many message queues are there supported? Does it support Kafka? Does it support RabbitMQ? Does it support NATS, Amazon SQS, Azure Q, whatever it's called? So there's so many different possibilities to invoke a function, so you can kind of judge the platform by looking at those triggers, maybe specific to your use case. Yeah, how well does it integrate with the existing infrastructure? Does it adhere to standards, to the cloud event standard, for example? And last but not least, not super important, but you know, how about the performance? How good is this cold startup performance? Imagine you have your function deployed. It's not running because you don't have requests. The first request comes in. How fast does the function start? Okay? How fast does the platform realize, hey, there's a request for this function, and fires up the function? And how well is the throughput overall once the function is hot and ready to go? Now let's go back to the landscape. Now, the first part was easy. Since I want to deploy this on this one and on a shared OpenShift PaaS, all hosted ones were out of scope anyway. Okay? That doesn't mean that they're bad. Okay? I mean, hosted, AWS Lambda, Google Cloud Function, Azure Function, and so many more. Okay? But they were, because they're hosted, they were kind of out of scope, and I kind of concentrated on the installable ones. Out of the installable ones, I can X out the next ones because they're not open source, right? So these are mainly, yeah, paid features, paid platforms, where you get maybe a 14 days trial key, but they're not really open source. The next thing I X out is something called, it's an installable component. It's the virtual kubelet. This is a thing really specific to Kubernetes. It's a cool project. What you can do with this one is you can kind of transparently extend your Kubernetes cluster by dynamic resources which you allocate in Google Compute Engine, for example. Okay, so this is a neat project, but not what I needed. The next three, I want to give you a few more details. Have you heard of Knative? Who's heard of Knative? Super hot at the moment. One hand, two hands, right? So what is Knative? Well, Knative, in my opinion, is not really a FaaS platform. It's the basis for upcoming FaaS platforms. So Knative is a Kubernetes-based platform, you can guess by the K, to build, deploy, and manage serverless workloads. So it can build, the build part, you give it code, and Knative will take care of transforming this code into a Docker container, okay? So the whole containerization of your code will be on the platform, will be within Kubernetes. The Knative serving part is exactly the missing piece, okay? So this is for scale to zero request-driven compute model. And it basically leverages Istio at the moment. And this is really neat because you can combine Knative with your microservice architectures at the moment already and have like scale to zero pods. So if your pods don't get any requests, Knative will take care of killing all the pods. So you're down to zero replicas, and if the next request comes in, it will fire up your microservice again. Okay, so Knative would put you in a position to have a scale to zero request-driven compute model for microservices already. And the eventing part is now for the loose coupling for event sources and event consumers. Riff, very young project. Definitely have a look at this one and keep it on your radar. This kind of combines Knative serving and Knative eventing with something called Cloud Native build packs. And if you've used Cloud Foundry before, you're aware of this build pack concept. And what they try to do here with the Cloud Native build packs is exactly to have exactly this. So again, to hide more complexity from us developers so we can concentrate on the business code. Kuma, super big, full-blown serverless platform backed by SAP at the moment, I think. They just migrated all their stuff to Knative and Istio. This is kind of, I haven't tested it. I've seen a talk on Kuma and I was blown away, okay? But Kuma is definitely not lightweight, okay? It's a full-blown platform, stick it on your cluster and go the Kuma way. So this kind of, was not suitable, definitely not for this one here, and definitely not for the enterprise use case I was after. So, X'd out a few more, and those are the main contenders left. Project called Fission, FN project. Anyone seen the talk by David Lebowski this morning on FN Project 1? You have Kubeless, a project called Nucleo, OpenFaas, and Open Whisk. So those are the 6 left from the cloud-native computing landscape. So let's have a look at those 6. Now, I'm aware that those comparisons now, they're always a bit tricky, okay? All those figures here, they're probably outdated right now. But they should give you an impression, okay? Regarding the contributors, regarding the releases at the moment, regarding the Github Stars, where you can kind of, deduce popularity, maybe. I have the amount of issues filtered down to bugs, and I have a column for, how's the current build status. And as you see here, contributors, well, Open Whisk is by far the biggest at the moment. Well, Open Whisk, backed by IBM, big, huge project, is part of the Apache Sandbox or incubator at the moment. Thus, they only have 1 release. They're quite popular, but unfortunately, they have quite a few bugs, okay? I mean, it's a big thing, okay? And they have quite a few bugs and a lot of issues. And for some reason, the build is red on GitHub, which I find a bit unfortunate. FN project, the next one, decent amount of contributors, a lot of releases. I don't know what they do, but they have like super micro releases. So a lot of micro releases. Also 4,000 stars, a few bugs and a few issues. Build is running, and you see down here regarding stars, OpenFaas, the second from the bottom, has here in this thing 14,510. The main contributor from OpenFaas reminded me that they have a lot of more stars. This is only from the main repository. Like OpenFaas is a huge project. They have like several repositories. If you count everything up, you probably come to, I don't know, 18, 19,000 stars. But here you have this. All nice friendly license, Apache 2 and MIT. So this looks fairly good. Right? If you ask Google, you see, hey, OpenFaas seems to be super popular here, Open Whisk as well. A bit of Kubeless and Fission and FN project, they're hardly on this map here, right? Okay, let's look a little deeper. Most of them are implemented in Go. I think it's a super sound choice for cloud native, platform stuff. Only Open Whisk, it's mainly implemented in Scala. Use cases, mostly enterprise. Some of them IoT. OpenFaas and Nucleo have also IoT as a use case. And Open Whisk and FN project, I would suggest they're kind of also for a hosted environment. Well, kind of only guessing here. I mean, Open Whisk is backed by IBM. IBM has a cloud offering, so probably the cloud offering by IBM is based on Open Whisk. And Oracle also has a cloud offering, so I would guess their function as a service cloud offering is based on FN project. But that's just a guess. Then I have this column generation, and I show you later in the demo what I mean with first and second generation. First generation is basically you still feel that you're building containers because you have all of those have a CLI, okay? And for most of them, for the first generation, what you do is like CLI build, CLI push, CLI deploy. This is like first generation. This is like Docker build, Docker push, kubectl deploy, yeah, or kubectl apply. This is kind of this approach. And with the second generation, all you do is give them a piece of code, deploy, and the platform does everything. Of course, the platform probably builds a Docker container underneath, but I don't have to care anymore. You see the supported platforms. So most of them, or all of them, support Kubernetes. Some of them can be run in plain Docker locally, which is always nice, especially for this use case here. And some of them have special support for Mesos, for example, for OpenShift, for AWS, for Google Compute Engine. I have a column with runtimes. We don't go through them, and a column with triggers. I mean, basically, choose the ones that suit your use case, right? I mean, they all support JavaScript, they all support Go, most of them support Java, so you're pretty covered on the language side anyway. And regarding the triggers, yeah, well, all of them support HTTP trigger, most of them support Kafka as, one message bus, for example, and other cloud-specific stuff. I think that's exactly the last slide. Then we go to the demo. Again, here, this was kind of, how easy was it to install these things? Do they have Helm, for example, as a packaging mechanism, or do I have to, deploy manually some Kubernetes YAML files? Kind of important here. The scheduler one is really important to me. Okay. So to my knowledge, Open Whisk and definitely FN project, they have a custom scheduler. So what does that mean? Well, that means that if you deploy it on Kubernetes, the functions are not scheduled using Kubernetes. So what they do is they schedule the functions underneath Kubernetes using the Docker socket. And this is in a shared platform as a service environment, is this a no-go criteria, right? I cannot tell my ops team, well, we have this platform as a service, but please let my component talk to the Docker daemon directly. This is like a super security leak. So this was the reason why at that point I said, like, okay, I can't look at Open Whisk or FN project. Well, it's not worth anymore because I cannot use it in an enterprise environment. So the ones left here are then OpenFaas, Kubeless, Nucleo, and Fission. They all have decent performance, they all have good documentation, they all have a good ecosystem. So in the end, my real shortlist were those four, the four at the top. Now, I can't show you everything, but what I recommend to you, the demo. I have a demo prepared for all four of those, okay? What you can do is go to this GitHub repo here, okay, the big cloud FaaS Lebowski. I have written a bit of documentation how you can get things up and running. The whole demo is based on Google Compute Engine, so all you need is a credit card and a Google Compute Engine account, and I'm pretty sure you can make this work on AKS, for example, on Amazon Kubernetes services as well, with a bit of tweaking, obviously. Okay, so what I want to show you first is, so here you see the README. I've already done this, fire up the Kubernetes cluster, did a few preparations, and what I want to start off is, let's install Fission, okay? So what Fission does now here is, it uses the Helm chart, the official Helm chart. There are 2 Helm charts available. Fission Core, this is like the bare minimum installation, and Fission Full, which is like brings its own diagnosability stack, its own elk stack, and so on and so forth. So that's been, pretty straightforward. If you're interested what this actually did, this is just a bit of makefile magic, so nothing, nothing fancy. So basically, we just fired up those 3 commands here. Okay. So I say Helm install Fission please into this specific namespace, and then deploy a few more YAML files. So let's see. So we go into the Fission directory, and what Fission has is this concept of so-called environments. And this is a pretty neat feature, I think. So for every language you want to support, you need to install a so-called Fission environment. And this Fission environment is then the basic runtime for all those functions that are written in this language. So here, I now create a environment for the Go language, okay? So let's fire up those here. So what you see here, under the hood, what it already created is a pod, a service, a deployment, and a replica set for building Go containers in this namespace. And in this namespace here, in the function namespace, you have those pool managers. So those are the pre-allocated, runtime, and they do this to reduce the cold startup performance, right? So you always have those running, but the functions are not. But this ensures that the functions are, starting up quickly. So this is kind of a semi-hot thing. I think this is a pretty cool idea. Okay, so this is basic stuff. Now, let's have a look. I mean, this is now super hello world. So this is what the function looks like at the moment. So that's a small Go program. All you have to implement is this handler function, okay? So the handler function gets kind of a pointer to a response writer. This is where we write our response data to, and we get a structure about the request information, okay? Who invoked us, which endpoint, what user, which HTTP headers, those sort of things. So, Fission is a generation 2 platform. So all you see here is I say Fission fn create. So we create a function, we give it a name, we say which environment to use, we tell it which source code to use, and we say, hey, we want an entry point, and please, as an entry point, use this function named handler I just showed you. So we do this, and if we're quick now, so under the hood, what it of course does now, yeah, see here, it's environment Go, the status is running, and now the status is succeeded. And if you see from those lines here, under the hood, of course, it built the Go binary, okay, and it took the Go binary and then built a container and put it into this environment. So if I say now Fission function list, I have this one function which we just deployed, which is here. Well, I can invoke this function locally, okay? So hello from Fission. This is locally using their Fission CLI. Of course, that's not a proper use case. So what we want here is we want to expose our function using an HTTP trigger, so we can call it using an HTTP GET request. So I say Fission route create, I give it a name, I need to specify the function, I can specify the URL, I can say, hey, please use the Kubernetes ingress for this one, HTTP method get, and host should be Fission demo. So I do that, it says trigger created, and once I have the trigger created, I should be able to issue a basic HTTP request, and here we go, okay? So if you compare this to, hey, Hello World microservice, where you know maybe implemented in, I don't know, Micronaut or Spring Boot, or I mean, they're all not bad frameworks, but you have to do a lot more steps to get so far, right? You have to build the container, you have to build the binary, you have to build the container, you have to deploy the stuff, you have to write the YAML files. So a lot more complexity, and I think this is a lot easier in this use case. Now, even more demos, right? If you say, well, I don't like Go, you know, bit old language, which is not, but you know, I want to do the JVM. Well, of course, let's create a new JVM example environment. So we go into this Fission examples. So Fission has so we do a Maven clean package, okay? Right. Oh, okay, Java. Okay. So what this basically does now is, you know, builds an Uber-jar, okay? I'm sure you all know the concept of an Uber-jar, so the jar classes plus every library then it needs. And what you can then do is create a new Java function based on this code. Oh yeah, Fission dot hello world. Better? Function with the same name already exists? Ah, okay. Demo gods. Fission fn delete minus name hello JVM. Maybe a few words about the JVM implementation. I can show you the code, and I think this is a bit unfortunate on the Java side. If we have a look at the Fission example and the Java source code we just deploy. So this is this method here, okay? So a plain simple class implementing the function interface. The function interface itself comes from the IO Fission function, IO Fission context. But one thing you see here is we have two imports on Spring Framework. So what they did is they made their Fission Java API, well, depending on Spring. I would have wished I would have other choices. I mean, Spring is not a bad choice, okay? But as we all know, it's not the most lightweight choice which we can have. So maybe it would have been cooler to have a Spring option and a Java EE option and a plain Java option and a, I don't know, maybe a Micronaut option or something. So that we as developers have the choice of choosing the framework we build our functions with. Now with this current approach, you're stuck with Spring. Okay, so it's not bad, but I would have wished they would be a bit more transparent here and a bit more independent. Okay, so we have this function deleted. So let's try this again. Now we have the function created, okay? So we do here. So we can say Fission function list. Let's see if everything's there. Okay, so they have the hello JVM function. It's already running. Again, we can create a route for this one, and we're up and running. Like this, and hello world again. Okay, so that's Fission done. So my impression from Fission is it's a super easy, out-of-the-box working platform. Good support for languages, good support for many triggers. So for an enterprise use case, I would definitely say Fission is definitely usable. I won't show you Kubeless, but Kubeless is a lot simpler, okay? All Kubeless does is basically hide the stuff port deployment service. So under the hood, Kubeless basically only creates those for you and deploys it. So this makes it super easy to use, but yeah, it doesn't give you much more, okay? So it's super lightweight, but it doesn't give you much more. Okay, so then the other thing which I really like to show you is OpenFaas, because it's the most popular one. It's got a super vibrant community. They have a Slack channel, frequent releases, and OpenFaas I looked into because they are currently the only one that supports this here, okay? So ARM devices. All the others don't. Installing or running OpenFaas, you can use Docker Compose. So this is the stuff that would run on this little box, but you can use OpenFaas as well on Kubernetes, okay? So what we can do here is, now let's see. One more. Make OpenFaas install. Okay, I shouldn't have done that. Oh, let's see the make file. So again, here it's a simple make file for the OpenFaas installation. And what we do here, we quickly take out this one and make this one again. Okay, so it does create two namespaces. We add the Helm repository for it. And let's do this again. Yeah, I hope it's running. Okay, we do this. Up. We need to log in. Yep. What you see here is OpenFaas now is the bottom two. So we have like the OpenFaas namespace where the control plane is in. We have the OpenFaas namespace for all our functions. Fission had a similar approach for the builders, for the functions, and for the control plane. Now, what we do next is we do this, and this is now generation 1 for this one. So you say FaaS build, right? So you see under the hood, we're kind of creating a Docker container, right? Well, yesterday that was a lot faster. The next one would be the fast push, where I push now the container to a registry, and then I can say fast deploy, right? And this makes total sense if you're on a device like this here, right? Then that's the way to go. So the fast push, I did that in the preparation, so this one should be kind of fast, I hope. And and then we say deploy. Up. So it says, okay, I accepted your function. Let's see, kubectl, this one here. 1 minute left. Okay, so you see here, I already have my functions running. Now what I can do here is this one, okay. They have a separate gateway, and what I need to do here is like this, construct the proper URL. Oh no, typo. And there we have hello from OpenFaas at Devoxx, okay? So pretty simple as well, installs nicely on Kubernetes as well, plus it has the benefit of, you know, running on low-power ARM-based devices. Right, so quick wrap-up. Which one should I choose? Well, it depends on your use case, okay? I definitely don't say pick this one, pick this one, pick this one. I can tell you which one I picked, okay? But please make sure if you have this same, if you want to go this route as well, then make the comparison yourself. Make the performance measurements yourself, okay? For Fission, I would use for the enterprise environment. OpenFaas is definitely my recommendation for, you know, low-power devices, but also capable for enterprise development. Nucleo is super fast, lightweight, also a good choice, I think, and Kubeless is super lightweight. I would wait for Kubeless until it integrates with Knative. I think then they're really good. This might make up a good combination. Fork the stuff on GitHub if you want. Slides, code, plus the code for this one here is all on GitHub. Okay, so if you want to build one of those boxes yourself, feel free. And thank you.